Okay, now question 6. Lana sikhuluma chemical equilibrium. Check out the description box. Uzothola ama links for other recordings engwayenzile for this paper. So Lana they gave us a reaction where a potassium dichromate is formed when a nitric acid is slowly added to a potassium chromate solution. So this is the potassium chromate. Where are we? Oh, okay. Then change the color and the marker. Let's use it black. Okay, so this is the chromate solution, and then we are adding in nitrate slowly. Okay, so the chromate ions, these ones in the solution, reach equilibrium with the dichromate ions according to the following balanced ionic equation. So the spectator ions bawakhipile. So it's just the ionic reactions, right? The active ions, the active ions ngaphakathi kwele reaction. So with 6.1, they want us to define what is chemical equilibrium. So you know what? Define, but I'm not gonna write it down. Ne? Know all your definitions when it comes to chemistry or the Chetlia's principle, boiling point, organic chemistry, about vapor pressure, melting point. Know your definitions, but chemical equilibrium is it's when the rate of the forward reaction equals the rate of the reverse reaction. So get this right. Get this one right. Asize la kulo kanje ku 6.2. Ku 6.2, but a concentrated nitric acid solution is now added to the reaction. Nitric acid na an acid ngibona ngale hydrogen ion. So this is our nitric acid. Of course, it's not the full formula, but kwamele wazi ukuthi an acid is responsible for dissociating into ama hydrogen ions. So lana ke basibuza bathi what color change will be observed in the mixture. Choose from more yellow or more orange. Alright, this one, it should be obvious to you. Now we born at this kind of question. They are asking you about iloganj. Concentration. We are increasing a concentration. What does the equilibrium do? Is we counteract a little change and do what? Try to decrease the increase of concentration. Yeah. So it does the opposite. We are increaser. You're in equilibrium. No. Say decrease at here. So in order to decrease this rise in concentration in nitric acid, what is the equilibrium going to do? Is to favor the forward reaction. So more orange will appear. So the answer it should be more orange. Then C1 6.2.2. Why is that happening? Lapagu 6.2.1 explained in terms of ulichetla. It's the same thing I was trying to explain. Laguti the nitric acid ions okay, so singati the nitric acid ions okay, not ions, maybe the nitric acid. Oh yeah, the nitric acid ionizes completely. It ionizes completely in the solution. It is a strong base after all. Nitric acid ionizes completely in the solution. Thereby increasing thereby increasing the concentration the concentration of hydrogen ions. Lama hydrogen ions wethu la. The hydrogen ions, right? Therefore, equilibrium will oppose this change according to Le Chatelier. Therefore, favoring the forward reaction. Therefore, favoring the forward reaction, and then it decreases the concentration of hydrogen ions. Therefore, the concentration of therefore the forward reaction is favored. Maybe it's not Kubega City. Therefore favoring the forward reaction, and then more Cr2O7 2 minus ions, more of these ions will be produced, therefore making the solution more orange, something like that. So the structure of answering questions on Le Chatelier, always comment on equilibrium shift, right? Always comment on equilibrium shift and say if the forward or the reverse reaction is favored, and then just talk about iluganji, the Le Chatelier's principle when there's a sudden change, if whether it's concentration, it's pressure, or it's temperature, you need to know with the equilibrium reactor kanjani according to Le Chatelier's principle. Just comment on that now. Question. The structure is the same. This is a textbook kind of question, right? And so pendula like in a textbook. Okay. So 6.3, when the temperature of the original reaction is increased, it is observed that the color of the mixture changes to yellow. Another textbook example, 6.3. All right, maybe nangazama this one. Okay, 6.3. We now have when the temperature. Okay, so question. By increasing temperature, then it became more yellow. 6.3.1, is the forward reaction endothermic or exothermic? I'm gonna say exothermic. Yeah, I think the pencil writes better than the pen. Okay, so 6.3.2, we have to explain the answer in terms of Le Chatelier's principle. Okay, so Le Chatelier uthi an increase in temperature favors what? An increase in temperature favors what? The endothermic reaction, right? The endothermic reaction. So by increasing temperature to this equilibrium, then it became what? More yellow. It means that in reverse reaction, it's endothermic. It's endo. Remember, an increase in temperature favors the endothermic reaction. So, an increase in temperature, it becomes more yellow. It means that the reverse is endothermic reaction. But they're asking us, what is the forward reaction? The nature of the forward reaction, it means it's going to be an exothermic one. An exothermic one. Simple, yet it requires you to, have a little bit of logic now pendula lama questions. Alright, so question answer la explain. Okay, so we have to explain in terms of what is happening. It's the same thing I was explaining. Laguti, an increase in temperature favors the endothermic reaction. It favors the endothermic reaction. Full stop. Since iluganje yethu, since the reaction, asibe professional, since the equilibrium since the equilibrium turns yellow after a temperature increase, maybe ungaqhubeka uthi therefore the reverse reaction is endothermic, thus is endothermic, and the forward reaction is exothermic, right? And the forward reaction is exothermic. Okay, so I'm sure that you can write something better than low, right? I'm just giving you ideas with our my problems. Okay, then 6.3.2, this is how we answer this one. Then for the last one, the McDaddy of this question 6. But Lana, they want us to do what? To calculate, the X mole, is it? Okay, so we have 11 mole of Lama ions lawa and X mole of the hydrogen ions are initially added together to make a 0.5 cubic decimeter solution and allowed to react, right? So it's in a volume. When the reaction reaches equilibrium, the solution contains about 9 mole per cubic decimeter. So this is a concentration at equilibrium, right? When the reaction reaches equilibrium. Okay, so lama ions lawa is one of the products. Abane concentration of 9 mole per cubic decimeter at equilibrium. That's the product. Calculate the initial, so sifuna lo X loya, right? X mole of this guy, the hydrogen ions placed in the container if the equilibrium constant is. Okay. As erase Lana. And 6.4, I think we're gonna have to bring this table. So let's add this table. All right, again. So how many reactants do? Okay, so now 3. We're gonna have 3 because we only focus on our solutions. Liquid we do not include in the equilibrium constant calculation. So Lana, sinalama chromium ions, chromate ions, 4 2 minus, and then H plus, and then we have Cr2 O7 2 minus. Okay, so we have a mole ratio of 2 2 and 1. So labo 2 2 1 babuyaphi lama coefficients esiwabona lapha kule chemical balanced chemical equation. So initially, how much do I have? I have 11 moles of this. I have X mole of this. I have 0 mole for the product initially. Okay, what else do we have? And then at equilibrium, concentration at equilibrium is in a volume of 0.5 cubic decimeters. So at okay, concentration, this is at equilibrium. At equilibrium. Okay, concentration at equilibrium. How much do we have now? 1, 2, 3. 1, 2, 3. Okay, so how Sina 9. Sina 9. Sina 9. That's our concentration. That's our concentration. Equilibrium, number of moles. Used or formed, amount of moles. Start, amount of moles. I know table is a bit weird, ngithole from a textbook, so I decided to use this one. Bengafuna ukuyidraw, yabona. But the equilibrium stands for the number of moles at equilibrium, used or formed, amount of moles. Start, initial amount of moles. Alright, so Sina 9, and then we have a, okay, remember this is a concentration for the product at equilibrium. So the concentration at equilibrium, so tata this 9, see multiply, sifuna the number of moles at equilibrium, so tata the 9, see multiply by 0.5. I think it's gonna be 4.5, but that's a half, yeah. So, but just to double check, this is over, yes, 4.5. So equal to 4.5 mole. 4.5 mole. Okay. So therefore, how much? Remember, stoichiometry siyenzeka la, not at equilibrium, ne? Not at equilibrium. So the same amount of moles that was found at equilibrium is over the same amount of moles formed. We are dealing with the product. The amount lays of this amount, right? A product at equilibrium, if it's now 4.5, it means that the formed amount will be the same, is about 4.5. Now stoichiometry iyenzeka la, where something is used, the reactants are used and the products are formed on this row. So siyenzani ke, there's a ratio of 1 to 2 lana. 1 to 2, it means that the number of moles la azoba equal to 2 times 4.5. Answer, it's 9. Nangapa it's the same, kuyoba ubani uzoba 9. So therefore at equilibrium it's gonna be initial, or the start, minus uloganje. The number of moles here is 11 minus 9. The answer ubani 9, 10, 2. Then lana kuzoba ubani x minus 9. Now my answers were to at equilibrium. At equilibrium. Manje ge, we have to change this to ini ama concentration. So the concentration at equilibrium, ngoba the equilibrium, the equilibrium constant equation, if we substitute ini ama concentrations only. So sizoti 2 over the volume, which is 0.5. Answer 2 divided by 0.5 or 4. So that's the concentration. That's the concentration for Lama ions now, right? And then we're gonna have to calculate the concentration again. X minus 9. Sifuna calculator the x, right? Divided by 0.5. Divided by 0.5. Divided by 0.5. I'm thinking. Substitute that thing. Okay, the idea of having a fraction lapagu substitution yethu, it's a bit awkward nyana, but you know what, hide. Okay, so ngizo hide this back. Sine concentration at equilibrium for the product. We also have the concentration for the hydrogen ions at equilibrium. We also have the concentration for the chromate ions as well at equilibrium. So now we are ready to substitute to equilibrium equation yet. Equilibrium constant equation yet. Okay, so Lanago 6.4, this is what we're gonna do. Kc value is equal to products, right? The concentration of the product to Cr2 0.7 minus over CrO4 2 minus squared. It's the coefficient. Then siba no hydrogen ion squared. Siya substitute. We are given the equilibrium constant to 0.09 equal to, we have this 9, right? 9 over CrO4 CrO4 let me go back. Oh, hydrogen, so it's 4. It's gonna be 4, I think so CrO4 kuzoba 4 la squared. Uyabona na le issue enginayo, x minus 9 over 0.5. This is the issue enginayo. We have a fraction ke manje, yeah? We have a fraction, which is something I don't want to deal with la. Nah, it's unprofessional ukudila nayo. But can we though? Can we? Okay, I sum this. I don't want to complicate it. So cross multiply. What is 1 times 9? The answer is gonna be 9. Then you have about 0.09 multiplied by what is 4 squared to 16, open bracket, x minus 9 over 0.5 squared. What is 0.09 multiplied by 16? I'm getting 1.44. Then sibano x minus 9 over 0.5 squared equal to 9. Divide both sides by 1.44. So 9 divided by 1.44, sithola 6.25. Then sibano x minus 9 over 0.5. So algebra in action gela. 6.25. Tata the square root for this. Then go about x minus 9. 8 marks, okay. Yeah, I guess. So the answer should be positive. Remember, a square root produces a plus or a minus, but we should have a positive. So 2.5 multiplying 0.5. I'm cross multiplying again. 0.5 into 1.25. Then go about x minus 9 equal to 1.25. Then transpose the 9, we now have a 10.25 mole. Ta-da! Okay, so this is our x value, right? This is our x value, the number of moles, the initial moles for the hydrogen ions. So this concludes our discussion on question 6, chemical equilibrium. I hope we enjoy it. I hope you have gained something. If you did, ungakhohlwa ukulike, ukushare, nokusubscribe. Please also check out the description box. There are links for other recordings for this paper. So for now, I'm signing out, guys. Sharp.